Yeah, I'm an Arsenal fan.
Oh, so you're even happier. Are you looking forward to the weekend?
Yeah, you wait till Saturday.
Well, I'm a Liverpool fan, so we were never going to win against AC Milan, and I was in Istanbul on the 25th of May 2005, and it was bedlam.
Cloud storage, and the cloud is affordable, and the cloud is good, and everything else. But 10 years ago, a petabyte of storage was in 10 racks.
Yeah.
This is the stupidity of it, isn't it?
Your storage is under attack. Your team has seconds to respond. IBM FlashSystem guarantees ransomware detection in under 60 seconds, backed by a legal contract. And it fits 20 petabytes into just 18U, while competitors need over 100. If you're responsible for enterprise infrastructure, this is the conversation you need to hear. Let's dive in.
Hi, I'm Ray Quattromini from Fortuna Data. Welcome to Smarter Strategic Thinking. Today we have Alex MacIndoe talking about IBM Flash Storage. Alex, pleasure to meet you. Thank you for coming in. Tell us a bit about your background and your role in IBM.
Been around the storage market for about 20 years. Started off doing the basics, right? So installing tape drives, cleaning tape drives, fixing tape drives, and then you move up to disks and arrays. Started off on the technical side, so really getting my hands dirty. And then I slowly went on from technical side onto more of a pre-sale side, more of a consultancy side. And I went through the backup side as well with Veritas and the Symantec side. And then eventually I ended up at IBM about 7 years ago, and I transitioned from the technical side all the way onto the sales side now. So my current role at IBM is to kind of look after the flash systems from a sales point of view in the UK. You know, every day I am just traveling to different business partners or different customers to talk about our new flash systems, which we released a new batch in February this year.
Tell our audience what IBM's flash systems are and where you start from a footprint and where you go in terms of capacities.
Sure, we've kind of condensed our flash systems this year, so we only really have 3 models. They're called the 5600, the 7600, and the 9600. With each model, they go up in size and in slot count, and the amount of memory and cache that you can have with them.
From a capacity point of view, where do they start and where does it end?
We have about 5 or 6 different size of FlashCore modules. So they start off at single digits, and you don't have to fill the box up with all of the drives straight away. So you can have 4 or 5 drives, depending on what your use case is. And then you can go all the way up to a 9600, which has got, 32 slots, and you can fill them all up. And the largest FlashCore module we've got is currently 105 terabytes. And with data reduction, with 5, you can get 5 to 1 on certain data. There's a hell of a lot of data in one FlashCore module.
Yes.
And of course, you can then start to daisy chain these arrays to get to, petabytes of the stuff.
Yeah. In a tiny footprint.
In a very, very small footprint, yeah. And, the 9600 is 2U.
In terms of storage density, it's 5 times more dense than anyone else on the planet.
Yeah, so we've recently done some research because of the new models that came out in February. So, we look at our competitors, obviously, and I didn't know how big this margin was. So if I take 20 petabytes and I do it a 1-to-1 ratio, so I'm not using any data reduction here at all, we are 18U. Our nearest competitor is over 100U. 5 times more physical space. You have to worry about tiles and everything and weight load in data centers, but then it's also cooling and power. With less storage, less power and cooling. On a day like today is also very important.
It is sunny, by the way, for our viewers out there. It's due to get 30 degrees today. So IBM Storage has gone for a big transformation over the last few years. From your perspective, what's the most exciting shift you've seen of how customers think about storage?
Come a long way. So I'm 20 years in, which is, some people will say that's a lot, and then some people will say it's not a lot, especially with the IBM tenure. A lot of people are 10, 20, yes. 30 years in. I've seen it go from physical media, from floppy drives, from 5.25 inch to 3.5, and all the way up to what we see now is 105 terabytes in your hand. And by the end of the year, we're going to have 200 terabytes in your hand. And with 5-to-1 compression, that's a petabyte in your hand.
And that's an FCM there.
This is an FCM here, yeah. So the biggest change I've seen is the consolidation of the size. This is before we start talking about AI and everything else. Is I'm going into customers who have bought storage 5 years ago, and it could be from us, it could be from our competitors, and they have racks of the stuff. They've got 4 or 5 or 6 racks, and they go, well, you're going to replace it with 4U or 8U or something like that. And that's the biggest change I've seen recently, is just the consolidation of the size and how much data you can get in such a small form factor these days. obviously we've now got storage for AI and we've got storage for cyber resilience, which is even
Yes.
it's becoming more and more feature rich. It's not just block storage. 5-10 years ago, it was block storage. You may have got some data reduction, provision it, and you align it to a server. But now it's got so much more intelligence in there, and it's really giving the value back to the customers.
The 9500 was for you, the 9600 is to you. Now storing 3.3 petabytes into you. How does the density stack up against the competitors? What's driving this real world decision?
We've done the research against Dell, Pure, HP, etc., and we are 18U. I can't remember the exact figures, but we are 18U for 20 petabytes. Pure are 121. Dell are 131 or something like that. They're all over 100. Not sure why they are over 100 when we look at these and this is our latest FlashCore module, and this is I think this is I'll have to read the back of there, but I think this is 40 terabytes. So it's not the big ones and it's not the small ones. It's halfway between.
But even the big one, 105, is still the same footprint.
It's still the same. We don't change the footprint. We just add more memory cores on here. And if I open it up, this is why we can store so much. It's double sided, so I can open it up and it flips over like this, and you can see there's more memory chips on there. And this is how we get the density on there.
And you make these?
We make these. These have got our logo on it. With the market going at the moment, which is really key, because we make them, we don't buy them in. Can actually help with supply. Still got a 40-day lead time on our kits, which is pretty good compared to our competitors. I've heard lots of horror stories of I don't know when the kit's turning up, let alone it's coming in a couple of months. But because we make these, we've sourced supply for the actual memory chips until years ahead. We have to give it to our supply chain manager. He's done a really good job, regardless of the features and the functions, everything else. Just reacting to the market at the moment and being able to serve our customers, deliver to our customers is quite key at the moment.
Your secret sauce, if I can call it that, is that shiny thing on the top.
Yeah, we've got a couple of things. So we've got these CPUs. So we've got a CPU on every single FlashCore module. I don't think anybody else does this. This is quite a unique selling point for us. And what this enables us to do is we can turn on all these extra features. So we can turn on the hardware data reduction, the compression. We can turn on cyber resiliency checks, so we can actually scan for ransomware without having to overload the controller. In a normal world, you'd have to, you turn on all of these features and all of the processing would go up to the controllers inside the chassis, whereas we still have those controllers in the chassis, but we get a lot of extra help from every single FlashCore module because it has this CPU.
And that's your custom designed ASIC, isn't it?
Absolutely, yep. So this is ours, and then we also have a unique IP on the actual memory chips as well. So the QLCs, so each memory chip, they're called QLCs, so the quads, which means 4 bits per memory core. And then what we do is we mix the QLCs with the SLCs, which is the single bits. And because we can mix the QLCs with the SLCs, what we can do is we can actually get to the speed and the endurance of the TLCs, which are the industry standard and the best of the best, which is TLCs is 3. So it goes from single to 3 to 4. So that's how we kind of, we mix the QLCs with the SLCs to make it behave like a TLC.
And I heard a really interesting stat. Your FlashCore modules, which you've had for 8-9 years now, you've never, ever, ever had a failure.
No, so from an endurance point of view, I'm going to touch wood because it hasn't happened yet, but we haven't had to replace one in the field. I think the last count that we had over 1 million shipped. We've never had to replace one from an endurance point of view. They haven't worn out yet. So whoever's created the IP for the QLCs and the SLCs and everything else, they've done a really good job. And it's actually a lot of the IP is created in Hursley in the UK. Right. So it's quite it's quite close to us. It's quite close to us right now, and it's great that to hear from, so especially from a big American company like that. With the UK is helping out on keeping these FlashCore modules the latest and greatest. Yeah,
no, it's amazing. I'm constantly flabbergasted that by the end of this year we'll have a petabyte in that footprint. It's mad. I
don't know if you've ever had a Google of how much data a petabyte is, but it's an astonishing amount of HD videos. I think it's like 770,000 HD videos in the palm of your hand.
It's crazy. FlashSystem AI is described as an acting agent for co-administrators trained on tens of billions of data points. In plain terms, for a customer who's never used AI-driven storage, what does this feel like using IBM's Flash systems?
It's a really good question. This is a brand new feature out this year. So it was only introduced with the 56, the 76 and the 96, and it's called FlashSystem AI, as you said. Yeah. And it's like having a virtual storage admin sitting on your shoulder. If you've got tasks to do, like creating LUNs, provisioning LUNs, if you've got alerts that are coming along, the FlashSystem AI will help you in a kind of a normal language kind of way. So instead of having to circumvent lots of different maybe screens and lots of different mouse clicks, you can actually chat to the Flash system, which is, you've got to get your head around that bit, first of all. So you actually have a chat window on the right-hand side, and you talk to it, and you'll say, in natural human language, you'll go, create 50 terabyte LUNs, and you maybe give them a name. So you say, call them 1, 2, 3, 4, and assign them to server 1, 2, 3, 4. Press enter. And the Flash system will go away, and it will say, right, this is what I think you said. So it will actually kind of summarize what you've said. Yeah. And it will say, here's the run book to do that. Do you approve? And you press approve, it goes away and does it. So it's that's why we say it's like having a virtual storage admin on your shoulder, because it goes away and does those jobs for you without you having to go through a week's course or
command line. That's a bit of a game changer. It's a bit of a time saver as well.
When we launched this in February, we had a lot of people in the room, and there was lots of customers, lots of business partners, and I heard the words cool and exciting for the very first time when you're talking about storage, because they were watching FlashSystem AI working. That's the reactive way the FlashSystem AI works. It also works proactively as well. So if you have alerts, because I said earlier about alerts, if you have, let's say a performance alert. So if a workload is hitting the I/O limit, it may recommend some changes. If let's say there's a cyber resiliency incident, it will recommend some changes, and it will say, maybe you want to do this, and you go, oh, actually, yeah, I would like to move the workload from maybe an old Flash system to a newer Flash system, because it's faster, it's better, it's more suited for that workload, and then it will, give you the run book, it will say approve,
yes,
and it'll go away and do it.
This is crazy. From when I remember entering command lines and what's the LUN of that, and what's the worldwide name of this, and how do you map this, and it does it all for you.
Well, I'm pretty sure we've all I've definitely made some mistakes on which LUN to assign or which one to do this and stuff like that. So hopefully it could take some of that away. It also maybe speed things up as well. So hopefully it will. Our idea was they can do things a lot quicker, so they can get more of their jobs out of the way, so they could maybe then go and be more innovative. So it's all about trying to free up some time for the storage admin to maybe look at what's coming out next. So what storage do I may need for containers? Because the application world is shifting to containers. Maybe they want to learn or set up what storage they need for containers, or what storage they need for AI or something like that. So it's all about trying to free up some time for the storage admin to go and do something, that's giving back for the company.
FlashSystem.ai, can you explain its decision and generate compliance documentation? For a Fortuna customer in a regulated industry, how does that audit trail work in practice?
Obviously, everything you type and everything it says is saved, right? It all goes into the log files. So if anyone wanted to go and have a look at that, for a regulatory purpose, why did you make that decision, or why did you do that? All audited, right? So you can have a look at it. You can search through it at a later date, because a regulatory board might need to have a look at that.
You talk about FlashSystem AI. If I was a rogue operator and I want to delete some LUNs or storage, what prevents me from doing that?
So the good thing is FlashSystem AI has not been taught, because it is a language model at the end of the day, it hasn't been taught how to do anything destructive. So if you did type in delete LUN 1, it would actually come back and say, I do not understand the command. So it hasn't been taught anything destructive. But on top of that, what you'd have to do is you have to go out of FlashSystem AI and go onto the normal GUI that you'd normally, and then you'd have to delete it through there. But what we can do is we can turn on something called that. So a second approver has to approve anything destructive. So we can add on layers of defense against a rogue insider, or someone who wanted to do something destructive, to make sure two people have to approve anything that's destructive.
FlashSystem AI automates provisioning, tuning, diagnostics and remediation. Can it assist with initial configuration as well, or is it more an ongoing operational tool that is already set up?
It's a bit of both, right? So obviously it can't do anything physical, so it can't physically put the rack in for you. But as soon as it's up and running, you can then start to ask FlashSystem AI to start provisioning. So if you needed to create obviously quite a few LUNs, you need to provision the LUNs. You can write it all down inside the FlashSystem AI to create the runbook to run those commands. So it is a bit of both. It can help you set up, because a lot of the setup in a storage device is creating the LUNs and provisioning the LUNs, and then also setting up the policies for HA and DR. So, if you need any replication, if you need any mirroring, you can do all of that in FlashSystem.
Could I ask AI, what are the performance metrics for certain systems? Or
Yep, absolutely. So, and that's where the proactive side of FlashSystem AI comes in. So, if it's monitoring a workload, and you do have to tell it what the kind of the limits are. So, if you've got a workload that needs this certain limit, it will then monitor that limit, and if it breaks the limit, that's when it will proactively say it's running too. This FlashSystem is running too slow for this workload. You might want to move it to something faster.
if I'm an administrator and I want to show my boss that my systems are running pretty good, or not, as the case may be, could I then get a nice little graph printed and say, here, boss, this is what it is. We need some more storage, or something's going amiss, or
absolutely, yeah. So you can see the spikes of the I/O, and you can save those as a report, and you can print them out, and it will show you where your line of the policy is, and it will show you where the spikes are. So it will, if there are any spikes, you don't have to have spikes, but it will show you where the spikes are and what time they are. So you could maybe even troubleshoot it to a point where, well,
what system comes on
exactly, what's spiking the I/O, because before you spend some money you might want to try and fix the spikes. But if it is, if it's overloaded, if there's too many users, or if the workload just needs more power, then obviously you can gain as much information from the flash system to then go to the boss and ask for some more money.
If a customer's workload changes significantly, say they move into AI training or spin up a new database, how quickly does FlashSystem recognise that it retunes the system without admin intervention?
Pretty instantly. So because we monitor every single I/O, and if it goes over your threshold, it will alert you straight away. So if you set a certain policy threshold and you hit it, it will alert you straight away.
And is it also self-tuning?
Kind of, yeah. What I said before was it will make recommendations. So because what we can do is, if you've got many flash systems, what we have is something called a flash system grid, and they can all be managed from kind of a single pane of glass. So if you've got some of the newer models with the new FlashCore modules, and some of the older ones with the older FlashCore modules, it can make recommendations and say this workload should maybe go on to one of the new flash systems because it's faster, it's got more capacity, and then what it'll do is it'll create a runbook of moving that workload over to the new flash system. A human has to approve it, and then it will move the workload, and it will be absolutely seamless to the end user. So there'll be no downtime needed. The user shouldn't know in the background that the workload has moved from one storage box to another storage box. Nice new flash system, which is the top speed.
You mentioned FlashGrid. Do you want to explain a little bit more about what FlashGrid is and how it would work in a customer's environment?
Absolutely. So as soon as you have multiple flash systems, before FlashSystem Grid, have multiple GUIs. So you'd have FlashSystem 1 GUI, FlashSystem 2 GUI, and you'd have to manage them separately. But now we have something FlashSystem Grid. So as long as your flash system supports the latest code, which could be an older model or the newer models, then we create FlashSystem Grid. And then that gives you one pane of glass to manage all of the flash systems and all of the policies, which could be a HA policy, it could be a DR policy, it could be just management policies and stuff like that. But you can all manage it from the one pane of glass rather than the multiple GUIs.
It also works cross-site.
Absolutely, yep. So if you've got a secondary site, or HA site or a DR site, then you set it all up from the FlashSystem Grid.
And it would then load balance and whatever it needs to do across.
Whatever your policies, if you've got synchronous or asynchronous replication, you set it all up from the FlashSystem Grid.
Each FCM5 checks drive stats every 2 seconds against ransomware patterns, detecting in under 1 minute. How does it detect false positives, and what's the response for automating it or stopping it? What actually says ransomware? What's the next thing?
It's a really good question. So it's what we call inline threat detection, and it happens via the CPU here. That's why we can turn on these nice features. And what we do is we actually monitor every single I/O into the drive, and we use the CPU for that. And because we monitor every single I/O, we get to learn a lot of the characteristics of the I/O pattern. And when the I/O pattern maybe changes, and we know what an I/O pattern looks like from a ransomware point of view, it's actually it's a mathematical term called the entropy level, which is how you measure randomness. So if the entropy level changes above our policy, what we do is we flag a ransomware an event, and it goes into the FlashSystem log, and it alerts the user or the storage admin that there is a ransomware level threat. We don't actually do anything apart from that. So we just alert. We don't block anything or change anything. We don't turn anything off, because we want the human to make the decision. So they can make the decision whether to pull the plug on the internet or turn the box off or do something with the workload. Or they can have a look at our safeguarded copy snapshots and then restore from an old from a snapshot. Because what we've had in the past, if for example, if someone forgets to tell the system that they turn on an encryption obviously, if you turn on IBM encryption, it looks like ransomware. So that's why a human will always make the last decision.
Right. And how many snapshots can the Flash systems actually hold?
It's all depending on how much space you've got. Because I think you'll run out of space before you run out of the logical limit of snapshots, because it's into the hundreds or the thousands. But it's it uses up a little bit of space every time you do a snapshot, because it recognises what's changed since the last snapshot. Going back to the ransomware, we will detect it in 60 seconds. That's actually a guarantee. We actually guarantee that with a legal contract with the customer, and then you go back to the snapshot. Just be aware that you need to make sure, obviously, when you go back to that snapshot, it's clean and everything else. So we've got tools out there as well called Sentinel that will make sure that snapshot is clean before you make the decision to go back to that.
And you can roll back, correct me if I'm wrong here, to a minute.
Yep, we guarantee that one as well. So our guarantee is to detect and restore from a ransomware level event in 60 seconds. If you can work that quickly, you can restore it in 60 seconds. But you do need to do due diligence to make sure that you're restoring back to the right snapshot.
Yes.
And that's why we've got tools like Sentinel to make sure that it's clean. You're not restoring ransomware, and you're restoring to a clean version of that snapshot.
The FCM5 does have hardware accelerated analytics on every I/O. What's the latency overhead of that, and how does IBM ensure that it doesn't impact production workload?
Well, again, I'm going to point to the CPU again. So this is what makes us not have the massive overheads that maybe some of our competitors have. So you can turn on all of the features that we've talked about: compression, and the inline threat detection, the hardware deduplication, and the CPU will take most of the work. Obviously, it's not going to be zero overhead, but it will be very, very minimal overhead, because this CPU will take all of that processing power off the controllers and keep it all on that CPU.
Well, Alex, that's really good, and hopefully everyone now will be knowing more about IBM FlashSystems. Thank you for your time. Give us a thumbs up, give us a like, and enjoy your day.